Okay, in this lesson, we are going to flesh out our fetch collections async generator function so that it actually performs the asynchronous call of getting the collections inside of our Firebase database. Before we continue though, there's a bit of a theoretical shift that we have to acknowledge about writing sagas that's different from how we wrote our thunks before. Now, when we moved our asynchronous code into our thunk code here, into our fetch collection start async method, what we did was that we moved the logic out of the shop component into this action, which was great. It was a great way for us to separate out that concern. However, when we did this, we had to essentially make this new action, which was a thunk action that would be the one that dispatched fetch collection start, or it would inside then dispatch the success or the failure. But this action was the thing that held the logic of dispatching the subsequent follow-up actions of updating our reducer or informing us that we had an error. Now, instead of doing it in an action, we now do it in a saga, which is also why we switched our action that we fire inside of our shop page back to the original fetch collection start action. We no longer need an asynchronous action, like our fetch collection start async, to handle that logic. We now move all of this into a saga, and then have the saga listen for the start of that API Redux chain that we have. Whether it be the start, success, or failure, all of that logic is now going to be encapsulated inside of our fetch collections async generator function. So let's start moving that code over. Well, the first thing we got to do is we are going to copy this code that has to deal with that asynchronous logic and write it in a generator fashion. Now, we no longer need this dispatch anymore because we're not dispatching it from our saga. We just need the base start to happen and then we listen for it. And we also need to bring in all of the tooling as well as the imported functionality that we need to use to do this logic. So we need to bring in the Firestore and the convert collection snapshot to map, right? We need our utility functions from Firebase utils. We also need our action creators from our shop actions. And the ones we need is our fetch collections success and our fetch collections failure. Now that we have those, we can comment this out and slowly modify our code to repeat what we were doing here before. Now, what we did here was that we got our collection ref. After that, we need to use this collection ref to actually get our snapshot. But unlike before where we're using a promised-oriented .then style, we are using a generator function, which is very similar to async await in the sense that when we set this new snapshot value equal to the yielded value of running collectionref.get, when this value comes back, it comes back in a promise form that gets resolved with the value of our collection reference, which is our snapshot. So instead of chaining .then and then getting the snapshot in the callback that we pass to our .then, just like with async await, we get it back at the constant value that we set on the left side of our yield. That value goes into this yield statement and will set into the snapshot value that we declared right here. Very similar to async await. And then we need to actually create our collections map. Now, I'm going to show you something a little different about the way that we actually invoke our convert collection snapshot to map method. We still set a collection map constant, except instead of calling convert collection snapshot to map this way, we're going to leverage another effect called call. Now, what call does is that call is the code. Call is the effect inside of our generator function that invokes the method. We can technically write this the exact same way, no problem. We can do this. But we want to yield this in case this call takes longer than we expect, right? We want to be able to use this call method whenever we can, which is an effect that invokes functions. All we did here, all the call syntax is it's a method that takes as its first argument some function or method, and then the subsequent arguments will be the parameters that you passed into this function call. And because we're yielding this call, it allows, again, us to defer control at this point of the execution back to the Saga middleware. So in case it needs to cancel, we give it another place where it's able to do so. Beyond that, this way of adding more yields wherever we can also makes it easier for us to test. But once we have our value of collections map, we're yielding again to the call, and that, once this value gets evaluated, will be set to our collections map. So that's one thing about call. We just have to keep this in mind. And I'll show you also wherever we can use it. It's just a habit that we have to get used to. After we do this, we want to fire off this collections map into a dispatched fetch collection success if successful. Now, you might be wondering, before we had a .catch on our promise, right? How do we actually resolve and make sure that we're catching our errors? Well, it's going to be exactly like async await, where we use a try catch block. So here I'm going to do my try and put my code inside. And then I'm going to catch my error. And then we'll dispatch the subsequent collections failure with the error message. The other thing to remember is that inside of a generator function, right, inside of our Saga generator function, Sagas do not dispatch actions using the dispatch keyword. Instead, they use another effect called put. Put is the Saga effect for creating actions. And it's exactly like dispatch. The only difference is we have to yield it, and we're just going to use it like a dispatch. So we'll say fetch collection success here and pass in our collections map. Because again, put just puts out or dispatches out an object, right, that it's expecting to have a type and a payload. And again, our fetch collection success, these are all our action generators. They're just functions that return us those objects. And inside of our error, we'll also yield our put fetch collections failure with the error.message. And that is how we've converted our code to now use and leverage the generator function syntax in order to create the asynchronous logic that we had before inside of a thunk. We now have it isolated into this fetch collection async generator function. It's now Sagafied. And if we go back to our app, we see that our app works. And when we look in our console, we'll actually see that fetch collections start happens. And then when it succeeds, you'll see here that it says that a Redux Saga action was the one that fired. So that's the main thing too, is that our logger is aware what type of action is being created. And these are Saga actions. They pretty much operate like our own actions, and our dispatches and our reducers and our middleware treat them the exact same like they're our actions. It's just for us to verify that these are also Saga actions, so we know where our actions are coming from. We'll see that all of our code in our application works the exact same, but the main difference is now we've moved our code out of our asynchronous action from before, right, when we were using thunks, and into a Saga. In the next lesson, we're going to take a deeper dive into these takes because we've just written some Sagas and there's probably still a couple questions that we need to resolve or at least take a deeper look at that we will explore in the next lesson.